Hello, in this video we'll talk about data warehouse framework and architectures from chapter 3. Now let's quickly look at a generic data warehouse framework. So what you would notice is that there are some major components such as the data source, the ETL process, the data warehouse or associated data parts. Then you will see various applications through which we can access these. So let's start by the data sources, which can come from different sources within the company, outside the company, such as the ERP or enterprise resource planning softwares, legacy data, maybe some point of sales data, other online data sources, some external data sources. So we can have a variety of data sources from which we will get the data for data warehouse. These data then need to go through a process called as ETL or extraction, transformation, and loading before they are ready to be loaded into the data warehouse or data mart. So we may be sometimes having data mart with the data warehouses, but sometimes we'll just have the data warehouse, no data mart. We also store metadata. Metadata are maintained so that they can be accessed by the IT personnel and users to understand what data is there in the data warehouse. Finally, we do have some application tools and middleware tools that will help enable access to the data warehouse. Several basic information systems architectures can be used for data warehousing. Mostly, these architectures are called as client-server or N-tier architectures, of which the 2-tier and 3-tier architectures are the most common ones. In a 3-tier architecture, the client or the front-end software allows users to analyze data from the warehouse or dependent data marts. Tier 2 or the data warehouse contains the data and the software. And finally, the Tier 3 contains data acquisition software or the backend. In case of a 2-tier architecture, the first tier is the client or the front-end software that allows the users to access and analyze the data from the data warehouse. And the second tier consists of both the backend as well as the data warehouse. So it consolidates the two layers and makes it more economical than the 3-tier structure. If you have a 2-tier structure with the independent data mart, then the client or the front-end software allows access of data from the data mart, and the tier 2 is going to contain the backend plus the data mart. We can also have a web-based data warehouse architecture. Data warehousing and the internet are two key technologies that offer solutions for managing enterprise data today. When we integrate both of these technologies, we come up with web-based data warehousing. It has 3-tiered architecture, which includes the PC client, the web server, and the application server. On the client side, the user needs an internet connection and a web browser. On the server side, the web server is used to manage the inflow and outflow of information between the client and the server, and it is backed by both a data warehouse as well as an application server. Overall, you can say that data warehouse architecture design can be categorized into enterprise-wide data warehouse or EDW design and the data mart design. However, there are some alternative designs which lie in between the two traditional architectural structures. So we can have an independent data mart structure. This is the simplest and the least costly architecture, which has some independent data marts built instead of a data warehouse. We can also have data mart bus architecture. This architecture involves the individual marts which are linked to each other via some kind of middleware. Another form can be hub and spoke architecture. This is one of the most famous data warehousing architecture today. Hub and spoke architecture is focused on building a scalable and maintainable infrastructure that includes a centralized data warehouse, and several dependent data marts. Another architecture is centralized data warehouse architecture, which is very similar to hub and spoke architecture, except there are no dependent data marts. And finally, we have federated data warehouse. In a federated architecture, existing decision support structures are left in place and data is accessed directly from those sources as needed. So, can you answer which architecture is the best? Not necessarily. Each architecture has its advantages and disadvantages. When choosing which data warehousing architecture should you use, there are some of the issues or questions that you can ask, such as which database management system should be used, which parallel processing system should be used, will the data migration tools be used to load data into the data warehouse, what tools will be used to support data retrieval and analysis. So these might give you some idea of what architecture would be best for your needs. Another set of factors that can affect this decision making are such as information interdependence between organizational units. So a lot of different units within the organization are going to be use same data or are sharing data, then you need something centralized rather than independent data marts. For example, other factors could be upper management's information needs. What kind of information do you need? What is the urgency of a data warehouse? The nature of end user task. What are some of the tasks that end user is doing? Are there any resource constraints? Maybe technical issues, social political factors. Other questions may involve things such as the strategic view of the data warehouse implementation. Uh, are the systems compatible with each other? So there can be a variety of factors.